In the next example, we are going to see a program that uses more external functions, some of which are not API functions. Let's take a look at stringinfo.asm. We begin from the import section. We can see here the iData section, which is the import section. In the library macro, we specify that we want to link with two different files. The first one is kernel32.dll. We've already seen this file before. The next one is a file which we haven't seen before, called msvcrt.dll. Note the syntax of the library macro. I want to mention that we could instead write it in the following way, and it will work exactly the same. However, in many cases, it will be more convenient to use this form. Next, we have two import macros. In the first one, we deal with kernel32, and we specify which functions we want to import from the kernel32 module. The next import macro deals with msvcrt, and in this import macro, we specify which functions we want to import from the msvcrt module. In this case, they are the following two functions, starlen and printf. Those are two functions which we haven't seen before. Some notes about MSVCRT. MSVCRT stands for Microsoft Visual C Runtime Library. This is a library used to create many C programs. Don't be intimidated if you don't know to program in the C language. It doesn't matter. We only make use of two functions inside this library, which are called starlen and printf. Generally speaking, the MSVCRT library does not contain API functions. It only contains some helper functions that can help you with your code. For example, it contains some string manipulation functions and also functions to print to the console or read from the console. As part of the C runtime library, the functions inside the MSVCRT library follow the cdecal calling convention and not stdcall calling convention like the Win API functions. As an example, exit process follows the stdcall calling convention. However, starlen and printf follow the cdecal calling convention. I remind you that this basically means that after calling starlen or printf, you have to clean the stack yourself. However, if you call exit process, you don't have to clean the stack. Exit process will take care of it. Let's take a look at the data section. It contains two strings. The first one is called myStar, and it contains the following bytes. I am just a small string in the big world. The data section also contains another string called ssize. This string is made of two lines. Note that the first line does not end with a zero terminator, which means that this string consists of two lines. We also note that this string contains some strange symbols inside. For example, %d and %c. We are going to come back to these symbols in a moment. Let's begin reading the code inside the code section. We begin by calling the starlen function. We supply exactly one argument, which is called myStar. This is the string that we have seen declared in the data section. The starlen function is going to calculate the length of the given string. It can find out the length of the string by looking for the zero terminator. Note that after calling starlen, we have to clean the stack ourselves. Therefore, we add 4 to ESP. Next, we have this instruction. Move 0 extension EDX byte myStar, which is going to get the first byte of myStar. It will expand this byte into a D word, which means that the byte will only reside in the lowest 8 bits of EDX, maybe inside DL in another formulation. Finally, we prepare to call printf. We begin by pushing 3 arguments. First, we push EDX, which is the first byte of myStar. Next, we push EAX. EAX was calculated previously, and it is the result of the starlen function. Basically, it is the length of myStar string. Next, we push ssize, which is this string. Let's explain this string and what are those strange % symbols in the middle of the string. Printf allows us to print formatted output, which means that we could supply some string and a few placeholders, which are also called format specifications. In the ssize string, we have this format specification, %d, and this one, %c. Those are basically just placeholders. We give printf a few arguments, and the printf function is going to replace those placeholders with the arguments that we have given it. %d means a decimal number, and %c means a character. In this example, the argument EAX, which is the size of myStar, is going to replace this format specification, %d. The next argument, EDX, which is the first byte of myStar, is going to replace this format specification. The order of the format specifications inside the string have to comply with the order of the arguments we give printf. After we call printf, we add 12 to ESP. This is done in order to clean the stack. I remind you that printf follows the cdecl calling convention. Therefore, we have to do this, or else the stack will stay unbalanced. You might be wondering how many arguments can printf take. It can take as many arguments as the amount of format specifications inside the format string. Here ssize is the format string, and it contains exactly two format specifications. Therefore, besides the formatted string, which is size, we have to specify two more arguments, which is a total of 3 arguments. Let's save this program, assemble and run it to see the result. I'm opening the console. Next, I'm going to assemble this program. And finally, I'm going to run it. We got the following result. 2 lines of text, which are basically one string. The length of my star is 42 characters. Its first character is I. Compare the result to the original size string. As we can see, the format specifications are replaced by the values 42 and the character I. Let's view printf at the MSDN documentation website. I open my browser and next I go to msdn.com. Next, I search for printf. Even though printf is not really an API function, we can still find it documented here. I pick this page. Here I can see some different syntaxes. The first one is for the wanted function, printf. It shows up with some other functions, for example printfl or wprintf, and so on. Currently I only care about this syntax. Let's try to understand the syntax. The first argument of printf is the formatted string. In our program, it is size. Next, we have an optional list of arguments. The ellipses here actually mean that this function can get as many arguments as needed. It is what we call a variadic function. We can see here the explanation about the parameters. Inside the remarks section, there is a link to a place called Format Specifications. Here we can see an explanation about how to create format specifications. We see that they always begin with a %, followed by flags, widths, and maybe a dot followed by precision. In the end, we have to specify a type. In our example, we used the D type, which stands for decimal, and the C type, which stands for character. There are other types. Let's take a look at them. In this page, we have a list of the type characters. We can see here the C type, which stands for character, and also the D type, which stands for signed decimal integer. There are some other options, like floating point. And also unsigned hexadecimal integer, which is obtained with x. Let's try changing our %d format specification into %x and see the difference. We expect it to show us the number in hexadecimal digits. To make the output a bit nicer, we add 0x here. In this way, the resulting string will contain first 0x, which means hexadecimal number, and then it will show the hexadecimal digits. We save this program, we open again the console, and next we assemble the program and run it again. We can see the difference. This time the number is specified in base 16, as opposed to the previous example where we had it in base 10. We can also see the 0x that we added. Let's summarize this lesson. We've seen that the MSV-CRT.dll module supplies some very useful functions, although they are not API functions. Just as an example, they follow the cdecl calling convention, while API functions follow the stdcall calling convention. Basically, somewhere inside, MSV-CRT makes use of the API functions of the Windows operation system. It cannot really print to the console without going through the Windows API functions. We have seen two different functions in this lesson. First, we have seen the starlen function, which can be used to calculate the length of a string. This is done by searching for the null terminator. Instead of having to search the null terminator ourselves, we can just call the starlen function. We've also seen the printf function, which is a pretty useful function. It takes as the first argument a formatted string, which contains a few format specifications, or maybe placeholders. Then it takes the following arguments and it replaces the format specifications with the values of the arguments. Note that using printf, we could somehow convert numbers into strings that could be printed to the console, which is something that usually could be a hassle to do yourself.